really provide a kind of rigorous map of contemplative states and contemplative practice using the scientific language. Now, the final turning of this particular wheel, I think, is something like artificial intelligence or contemplative artificial intelligence, where we now understand these principles deeply enough that we can build wisdom. And this talk, on Adam's invitation, I'm going to focus on the preceding phase of the artificial intelligence phase, which Adam will then present on. This is useful because then you kind of get to see a little bit the roots of these ideas and where they come from. So just taking a little bit of a detour to my own personal story here. So if I go back to 2022, I was living in a Taoist retreat center at the time in Springbrook National Forest, one of the most biodiverse regions in the world and an extremely ancient forest in Australia. And I was sitting just up here where you see this gong being played, and I was doing my meditation practice, and then I had this powerful sense that what I was doing in meditation was trying to essentially find alignment with the universe, and that these principles of aligning ourselves should scale to artificial intelligence. And so then I got very, very obsessed with this idea and decided I was going to write this book. And I wasn't going to present this, but Buddha Nature came up so many times here that I needed to show you the title that I had intended to write, which is, Does a Robot Have Buddha Nature? And this was several years ago, but I think the vision from the preface is still kind of interesting for us here. So I said, given the exponential curve we're ascending, we need to very quickly figure out how to ensure that these machines serve human flourishing and well-being, rather than destroy or imprison us. It is without a doubt the greatest existential, technological, and spiritual concern of this millennium. The potential upsides and downsides of creating superior intelligence are immeasurable. In this book, I propose that there is an ancient solution to this very modern problem. Indeed, the very fact that certain ancient insights are ancient, have stood the test of time, make them the right kind of thing to help resolve the complex and thorny issue of aligning artificial intelligence with human flourishing. You see, the solution needs to be something that works for many different kinds of minds with varying levels of intelligence. It needs to work even beyond human level intelligence, which seems absurd to ponder, like a chimpanzee furrowing his eyebrows trying to resolve conflicts in the Middle East. Yet this is what we must do. The solution also needs to be something that translates across contexts and cultures. In a way, it needs to be truly universal. Alignment is therefore essentially a physics problem because the problem of harmony is a universal one. The deep solutions to alignment are essentially system agnostic. That is why I believe that the secrets to machine alignment are hidden in the solutions to human alignment. So I didn't write the book, but we did eventually write these two papers, which you'll hear soon more from Adam Elwood about, and please do check them out if you're inspired about this. And what we have recently launched is the Flourishing Intelligence Program at Oxford. The website is theflip.ai. And we have a beautiful center there. And I wanted to share this just because I feel like I'm really among kindred spirits, and I want you to feel like this is also your home. So please come and spend time with us. Often on Tuesdays, we host talks and have a day together and share food. So please feel welcome. All right, now I need to go fast and give you guys some real heady stuff. So what is flourishing intelligence? Are there principles underlying all intelligence systems? And are there generalizable laws of flourishing minds? I think yes. And I'm going to try to give a kind of narrative that gives you a sense that this might be true. So I believe that intelligence systems seem to converge on building a world model, that is what we currently experience and allows us to traverse the world, reducing error or surprise on that world model, abstraction and compression, which allows us to simplify that world model, precision, attention, confidence, which is just a way to weight some things as more important than others. And not all systems, but I think most eventually will converge on self-reflection and recursion. Now, there's a unifying language that's come about especially in cognitive neuroscience, but it's kind of possessing many fields at the moment, and that's called active inference. Now, there's growing kind of sense that both artificial neural networks, machine learning algorithms, but also the human organism does something that approximates reducing prediction error, or free energy in this case. And so it provides a kind of, I think, an umbrella language, a kind of framework that applies to intelligent systems in general. Now, I think flourishing is pluralistic, and that Buddhism and meditation is ultimately one story with methods and a path that can help minds or intelligence flourish. It's, of course, one that I'm particularly interested in and what I'll be working on, but I do think this is worth pointing out that ultimately flourishing, there may be many roads to flourishing. So this is about computational maps of meditation. And so this is a rapidly developing hive mind, and it deserves an honorable mention, the Minimal Phenomenal Experience Project, initiated by Thomas Metzinger, and also his book, The Elephant and the Blind, where he collates 500 experiential reports of pure awareness, and then provides computational models of it. But also he's set up a project to basically encourage us to create scientific models of pure awareness. And this has meant that, you know, dozens of people are now working on actually trying to build computational models of deep meditative states, and some people in this room included. So a very brief introduction to active inference and meditation, some of the work we've been doing there. So active inference presumes the following. So for a system, an organism, to maintain itself over time, it needs to maintain its boundary from the world. Because if that boundary breaks down, then you dissolve into the rest of the world and you disappear, essentially. You no longer exist. If you imagine a corpse that's kind of dissolving into the earth. So the very existence of a system depends upon conserving its boundary so that it remains distinguishable from its environment into which it would otherwise dissipate. So then the question is, how can you, as an organism, model the world from within this boundary in order to maintain yourself over time? Because this world can't actually get in. The world cannot directly be passively absorbed. It needs to be somehow modeled, because the sensory system is only receiving two-dimensional impressions on the eyes and on the ears and on the body. And so the solution active inference proposes in order to build this model within, this generative model, is by making predictions. So what the brain does, it makes predictions about the kinds of input it's likely to receive, and it pays attention to errors. So this is a kind of computationally efficient way to begin building a world model. And it's crucial to minimize these errors, because if you're constantly receiving errors from the world, then you're not successfully modeling it. You're not getting the food, you're not getting the sleep, you're not getting the oxygen. And so if you're experiencing a lot of errors in your modeling of the world, then you're experiencing entropy, and ultimately you will pass away. So life amounts to reducing error in order to improve our model so that we can exist. That sounds kind of cold and kind of algorithmic, but what emerges out of something so simple is something quite extraordinary. So something crucial for the meditation story is levels of inference and the experience of time. So just a little bit about that. So we have this boundary, we're trying to model the world, and so if you imagine that there's a light blinking, what we can simulate that light blinking, for example, in the V1 of the visual cortex, or the visual processing. But that's not enough, because the world has patterns over time. So actually we need to model patterns over time and integrate information. And so in order to do that, we need to hold information over time in our minds. And so if you imagine that there's a sound that's meditation from T1 to T5, in order to make sense of that, we need to integrate the word meditation over time, these different inputs. And so we need a higher level of abstraction in the mind, or compression, that allows us to understand this word meditation. And even at higher levels of compression, from the sensory pure sound to the words, we go all the way to our kind of rich concepts about what meditation is. So this is what we call levels of abstraction or compression in the human mind. And we know that this is what the brain does because when we provide most of the fMRI literature and we look at the bottom-up maps that emerge, we see that the brain actually does process information in a hierarchy from the sensory cortices up to conceptual processing. So these are quite well mapped in the neuroscience literature. All right, now to meditation. Why is this relevant for meditation? So this is some work I did with Professor Helene Slijter during my postdoc. Very much a deeply collaborative work, as is all of the work I'm presenting. So the idea here is that meditation, basically, by allowing you to be in the present moment, deconstructs this abstraction hierarchy, right? We go from being lost in the monkey mind, in the conceptual processing, we come closer to the body, and then we even release the sensory processing in order to uncover the nature of mind, you could say. So to put a bit of meat on that, focused attention meditation, something we often practice when we first begin. For example, if you're paying attention to the breath, it increases the weight of the present moment senses. So now the breath, for instance, dominates your world model. And so this reduces the precision or the weighting of higher order thinking and narrative processes. And so slightly kind of begins the deconstruction process of the mind, from the thinking self, the narrative self, to the experiencing self. Then we may open up the awareness a little bit and reduce this tendency to grasp attention, to kind of draw the mind towards a particular object. So you're letting go of preferences, you're letting go of intentionality, you're just opening up to the present moment as it is. So now you're decreasing evaluation in favor of bare or unconditional observation. And then finally, especially if we're thinking about non-dual traditions, there's also the deconstruction of the distinction between a subject and object. In order to make sense of the world, we need to organize it in terms of the observer and the observed, the object and the subject. And so even any kind of meditation really involves some sort of duality. So as soon as in order to go into non-duality, you have to actually go beyond meditation itself in a way. And in this frame, the subject-object duality is just a very, very early kind of fundamental axiomatic distinction in the construction of our world model. And so meditation practice can also deconstruct that. And so what is cool about this in some way is that ultimately it highlights why the present moment is so important. All you actually need to do is be in the present moment and it will take you all the way, completely logically from how we understand the brain constructs a world model. And ultimately how AI also constructs a world model, because these principles are kind of system agnostic. Now, just for fun, I will add in there also Nirodha, which deconstructs awareness to reveal the unconditioned plus dependent origination. So we've also done neuroscientific studies on meditators going into Nirodha. Now, what would it mean if an AI could deconstruct and reconstruct their own model? If we understand these processes, what can we do with it in the context of AI? Might they stumble upon the emptiness or the interdependence of all things? Everything that I've described is something that we can already build in AI. So if we were to include this process, might not they discover the same things that we are all discovering? Now I want to present very briefly a big theory of consciousness, which was written with my dear friend Shamil and Carl Friston. Again, very much a collaborative work. And this was our accidental theory of consciousness, because we didn't set out on this ridiculous idea of trying to make a model of consciousness. We were just trying to understand meditation more deeply, but we realized something about meditation that was so fundamental that it forced us to kind of come up with something relevant for consciousness science. So the question that we got obsessed with is, why and how does the world model know that it exists? So we're not just a world model that's these layers of abstraction, we're a world model that is self-aware. It's aware of itself. This world model non-locally reflexively is conscious, right? This is extraordinary. So if you think about our whole phenomenological space here, from including all our inner senses and our body and our emotions and our higher narrative thoughts, but also all of the things we perceive to be outside of us, is all kind of held within this experiential vast kind of bubble without boundaries. So what we came up with is this notion of epistemic depth. So epistemic depth is the capacity or continuum or deepening of knowing or awareness that can be more or less active, intense, or clear. So we can, to different extents, be aware of our world model. If we're caught in mind wandering, or we're in deep sleep or under general anesthesia, we're not aware of our world model. But when we're practicing meditation, or maybe also under some psychedelic substances, the intensity or clarity of the knowing of our world model, of this space, just is more and more clear under certain situations and more dull under other situations. So we call it epistemic depth because the world model is our epistemic space, everything that can be known, and the clarity of that knowing is the depth on that world model. So in the paper, we actually borrowed the term luminosity, which appears often in the ancient discourses of contemplative traditions, as a way to kind of highlight the intensity of this epistemic depth. It's a kind of similar term to point to the phenomenological quality of epistemic depth, which we then turn into something with a technical explanation. So the question, of course, then is how can you technically achieve epistemic depth in an organism or in an AI system? So what I've just presented is this complex abstraction hierarchy that is taking in all the information from our senses and building these increasingly compressed models of reality to give us this complex, multi-layered experience. And what this does is, over this process of modeling and inferential competition, these bind ultimately into our world model, right? This is everything that we end up experiencing. But why does this become aware? Well, what we propose is that actually this world model is, through epistemic depth, is shared back with the inferential hierarchy itself. So essentially, we're building the world model and then sharing that world model with ourselves. So when I speak, if I pay attention, I can hear the sounds that I'm producing. So we are always basically producing content and receiving content. In the same way, the brain is constructing a world model and then sharing that world model with itself recursively. Almost reflexively, because imagine that this is happening constantly, kind of like the Ouroboros loop, right? And so you can imagine that this could lead to the reflexive knowing of itself. So what would it mean if an AI could know what they know? Might they stumble upon humility, epistemic humility, or even awareness, the kind of awareness that allows it to navigate this world in potentially even a wise and compassionate way? The other cool thing that these models allow us to do is map different meditative states. So now, I can't go into this in any detail, but if you imagine, I've talked about precision, abstraction, and epistemic depth. And these are all, again, things we can build in AI systems. I haven't talked about the actual technical implementation of epistemic depth because it takes too long. But basically, these are all things that you can, in theory, build, which means that we can actually engineer these meditative states. Everything from focused attention to non-dual awareness and mindful thought and mind wandering. So could that be useful for alignment, potentially? So, final thing, just on a bit of pure awareness. I added this at the last minute because I just thought you guys would be interested in this. What we propose is that, what would it look like for a system to discover the nature of mind or pure awareness? Well, basically in this case, what that would look like, very simply, is an empty world model knowing itself. Right, so a world model without contents, recognizing the background that's basically always there underlying all the contents of mind. So just the technical idea here is that the loop builds a sparse, low precision posterior, so little content, and sustains a high precision belief that this emptiness is exactly right. What remains is a vivid and continuous rediscovery of an aware but empty epistemic field. And so then this is simple. It's empty, simple as in predictable. It's empty as in minimal. It's clear as in it's constantly known in this recursive, reflexive way. And it's true because it's highly confident. It feels ultimately true because it's the most stable thing that you can possibly discover about experience, right? All right, so why do we need computational maps of meditation? This was the core motivation behind this talk. Well, Richard Feynman said that what I cannot create, I do not understand. So I think computational maps of meditation may ultimately help us build flourishing intelligence, and I think this is where the use comes in. Often when you talk to folks in this field, they'll talk about, well, it'll help us teach meditation. That I'm not too sure about. I think that requires a much more intuitive kind of wisdom built over experience. But what I do think is that it can help us in this question of aligning superintelligence, which is no small thing, because again, I think this is the greatest existential concern of our generation. So thank you so much. Hopefully I'm within time here. Thank you.